Hello everyone, it's Benny, and today we're continuing development of the 2D role-playing game, and just like always, we're going to do a really quick recap. So far, we set up the game engine, we have a player, we have items and inventory, and in the last video, we've set up enemies. Now, we haven't finished implementing our example enemy just yet, but so far, if I hit run, then you will be able to see with our amazing temporary graphics that I'm the player, the blue dot is a monster. If I'm just standing far away from him, he won't see me, but if I get too close, he sees me and he starts chasing after me. So, we have very basic AI going on here. But it's not done yet. We only have him being able to find a target and being able to chase after it. We also need the enemy to be able to attack the target and eventually be able to die as well. So that's what we're going to do in this video. So without further ado, let's get started. So first thing we're going to do is we are going to implement the attack method. Now in my enemy class, which is right here, we already have the basis for the attack method. It's already being called at the appropriate time, but you know, we aren't actually doing anything yet. So, I'm just going to first off override it. So, I'm going to override the, if I type override correctly, I'm going to override the attack method. So, and again, this method's inherited from the enemy class. And now we have to decide how we want our monster to attack. Since this is the cookie monster, I think it kind of makes sense that he only should attack within if he's close enough to the player to attack. So, I'm just going to determine if he's close enough using a simple distance check. So, we set up a utility method for the distance class in the last video, or the distance calculation in the last video. So I'm just going to check if util dot dist between our position, we can just pass in our x and y directly, and our target dot get x and target.getY. So all this is going to do is it's going to calculate the distance between us and the target. So if that is closer than a certain range. So now the question is, what do we want that range to be? And really we should create a constant for that, because that way we can easily change it and we can use it in multiple places, and it'll make it really easy to customize our enemy like that later on. So I'm going to create a constant. Public static final, and it'll be a float. I'm going to call it melee range, and we have to decide how big we want our enemy's melee range to be in terms of pixels. So I'm just going to start off with 32, and we'll see where we go from there. So while I'm at it, I'm also going to create a float for this sight range that we created in the last video. So I'm just going to call this sight range. Yeah, I'll call it that. Why not? Sight range, and I'm going to initialize this to 128. And I'm going to replace that with the sight range. And again, that's just going to determine how close we have to be to the enemy before he sees us. So, there's our enemy's range of sight, and now we can finish this. So if the distance between us and the target is less than our melee range, well actually, I'll do it if it's greater than melee range, then we're just going to end the calculation right here. So, first off, I'm getting an error. That's because I have to do get target, I forgot. We have to get our target, and then just get Y. And yeah. So now, if we're outside of melee range, it should just return. So, in theory, everything after this line should only be executed if we're in with if our enemy is close enough to perform a melee attack. So, if we're close enough to perform a melee attack, for now I'm just going to print out .println. For now I'm just going to print out we're attacking the player. And this is just because we don't really have a good health and damage system going on just yet. So, I'm just going to leave this as a temporary line of code until we do that. And in fact, just to make it clear that we need to do this, I'll just add a to-do statement that says, to-do, make enemy hurt the player. Not platter. Not, Okay, I guess. Anyways, so now if I just save and hit run, then it should be that our enemy sees us and he chases us. If he's close enough, then he's attacking us. Now this range is actually a little bit small because he has to literally be touching us to be attacking us. That's a little bit, it's not what I want. So I'm going to increase the melee range to 48. I'm going to see how that works out. So I'm going to wait. And, okay, I think I kind of like that distance. It's still a little short. I'll increase it to 56. And really this part right here is completely artistic. You can set the melee range and sight range to whatever you want. Whoop. Whoop. And, oh. Okay. I kind of like that range. I think that's a fair range. Maybe a little bit too much. I don't know. I'll leave it at 48. And, again, we can just see where we go from here, because that part's pretty much artistic. We can set it to whatever we feel like it should be. So, yeah. So there's the attack method. And now we have to implement the death method. What do we want the enemy to do when he dies? So, I'm just going to do override. It's going to be protected void die. Although I'm really not sure about the name die anymore. I kind of want to rename it. So I'm just going to do Control R. And yeah, okay, that's fine. I just want to rename it to def. I don't know, die seems too simple to me. So I'm going to call the method def. And this will, again, just be whatever happens when our enemy dies. And really, in this case, there's not much I want the enemy to do. If I had an enemy with a bunch of items, I'd want them to drop them or give them to the player or something, but for now, I'm just going to have the enemy despawn when he dies. So, I'm just going to say destroy. And the destroy method is implemented in the GameObject class, which is right here. And, oh, wait, it's remove, not destroy. Sorry. Remove, and this method we implemented in the GameObject class, and again, all it does, removes it from the game. So now, when our enemy dies, it will be removed. So that's great, and cannot find symbol player ID. Okay, this is interesting, because I'm pretty sure I accidentally commented that out for some reason. That's interesting. And there we go. Okay, so there we go. We have implemented the attack and death methods, at least as far as we can go without implementing some more game mechanics. So, why don't we, while we're at it, start implementing damage in combat, and let our player and enemy actually fight each other rather than And, I'm drawing a blank here, I'm sorry. Okay. So, I'm sorry. So, yeah, okay, whatever, you know what I mean. We're just going to implement combat. We're going to get us if they can attack each other, they can damage each other. Yeah, I don't know, I just had a total brain fart right there, I'm sorry. And yeah, that's what we're about to do. But, first off, I have a slight problem with what we have implemented so far. Because if I have the enemy chasing us, and he's attacking us, he'll still continue to chase us while he's attacking us. And, I don't really want the enemy to continue chasing the player when the enemy's already in melee range of the player. So, what I'm going to do is I'm actually going to move this melee range variable. I'm going to move that into the enemy class. Except I'm going to call it, not melee range, but just attack range. I'm not going to make it a constant. I'm just going to make it a float. A protected float. Called attack range. And this way, what I can do is I can remove this line of code right here out of the attack method. And I can move it in to the update method right here. So, and this might seem a little bit weird, but just go with me for a second here. So I'm going to change this if statement right here to say, if we have line of sight and the distance between us and the target is less than or equal to our attack range, then and only then do we attack. And am I having one too many close params? Yes, I did. Okay. And what I'm going to do is I'm going to move the chase statement and say, otherwise, we're going to chase the player. So we're only going to chase the player if we're not attacking the player. And I like that mechanic a lot better, personally. So now if I run, what should happen is he should continue to chase us, and then when he's in melee range, he'll stop chasing us. And then he'll only move if we run away from him. And I like that mechanic a lot better because that way the enemy's just not basically piling on top of us all the time. Just seems like a lot nicer of a mechanic. And this is... it does create an interesting effect, I'll give it that. But, yeah. So there. Now back to the task at hand, we're going to create damage methods. So, first off, there's a slight problem with damage methods right here. And that is, in our enemy class, our target is a game object. The problem is, not all game objects are going to be able to take damage. I mean, it wouldn't make a lot of sense if I'm trying to kill a sphere. I mean, unless it's this big evil monster sphere, it doesn't make a lot of sense to do that. So, what I'm going to do is I'm going to create a subclass of game object. And I'm just going to create it in the game object package. So I'm going to create a new Java class. And this will be, I'm going to call it a stat object. And this is going to be just like a game object. It's going to even extend game object. But what it's going to do is going to combine the thing that both our enemy and our player have right now. And that is, they both have statistics. So I'm going to take the statistics out of my player class, and I'm going to later do it in the enemy class as well. I'm going to move it to this stat object class. I'm going to change it to protected. Extends game object, cannot find symbol, Control-Shift-I. Problem solved. And that's all I'm going to add for now. And what I'm going to do is I'm going to change the player to, instead of extending game object, to extend this stat object. And this way, it gives me a clear basis for what I can have a target. It gives me some qualifications, because every target has to be able to take some damage. It can't just be... I can't be chasing after... I can't be trying to kill an item. You know, again, same situation. So there. And same case with enemy. Stat object. And again, getting rid of stats. So there. Now what I can do is I can change my target to a stat object as well. And I'm not entirely sure if that's going to work because, yeah, set target has to take a stat object. That could cause error somewhere else. No? I thought it would cause an error somewhere else. And right here, set target geo. Okay. So, this leads us back to an issue with our way of determining if the enemy is within range. Right now we're doing a sphere collision method. We're finding every enemy or every object within a sphere of our enemy, and if any of the objects in that sphere happen to be the player, then the enemy starts chasing it. Problem is, of course, this is a list of game objects. We don't want game objects, we want stat. Actually, perhaps, I don't know if this is going to work, but perhaps we can cast it to a stat object. I don't know if Java will let me, but it does. Okay. So that's solved me a bunch of code. But, okay, so there we go. That's the solution, I think. I'm just going to test it really quick to make sure it still works. Come on. And, yeah, it's still working just fine. Okay, then. Well, that solves that issue. But, of course, we have a couple more things we need to do. We still need to add damage. All we've really done so far is we've just created a new subclass of game object and said that enemy and player are both part of this subclass. That's not really useful to us unless the subclass does something more useful than just have a variable in common. And the way I'm going to solve this is with the damage methods. So I'm going to create a method in this class, just called, it's going to be public void called damage. It will take in an amount, and oh, okay, fair enough. And all this is going to do is this is going to decrement our, what's it called? Come on, you can do it. It's going to decrement our, why can I not think of this? Our health, there we go, by whatever amount we have. So, actually before I do that, in our, oh, we don't have an enemy class, but in our player class we have a bunch of getters for all the different stats. I think it'd be a lot nicer if I just took all of these and I moved them to the stat object class. That way, every object has these getters, because every object that's from the stat object type will always have these methods. And this also saves us from having to retype it in our enemy class, which we actually hadn't done yet. So there, that makes our code in our player class just that much cleaner. And think about it, right now we have a really, really complicated player system. It has inventory, it has statistics, they can level up, they have a whole bunch of different leveling algorithms and stuff. And this is all the code to it. This is it. So this just goes to show you the power of the object-oriented programming we've done so far. But anyways, back on topic. So, what I'm going to do in our damage method is I'm going to take our current health, which actually I'm going to check my stat class because I'm not sure if I have a method for setting current health. Okay. I do not have a method for setting current health. Okay, so in our stats class, I'm just going to create a public method called actually I'm just going to call this damage as well. And this way I can just use this one as a wrapper method for, I can just do stats.damage. And the reason I'm doing this is because the stats class has pretty much access to all these variables which deal with our statistics. And I'll just make this a lot easier, because I can just do health minus equals amount. And that should solve the issue. So, if that's doing everything I think it will, then that should allow us a very basic way of doing damage to both our enemy and our player. So, we just took out two birds with one stone in that case. But before we go any further in implementing this stuff, I want to address a small issue in our current combat system. If I hit run, and I get close to our enemy, he chases us, just like expected, but when he starts attacking us, he's hitting us at about 1,000,000 times a second. And unless he has some sort of hyper chain gun of doom, that's really not the effect we want. Especially since it's the Cookie Monster, because if the Cookie Monster has a giant chain gun of doom, then that's just plain terrifying. So, we're going to need some way of limiting the rate of attack. And this is actually a lot harder than it looks at first, because our frame rate, which is basically the whole basis of the system, we update once every frame, our frame rate has no consistent time. One frame could take 10 nanoseconds, and the next frame could take 10,000 seconds. So, since there's no consistency, it makes getting specific times really, really difficult. But over my years of just game development, I've came up with, I think, a really simple system of getting around this issue. And it's what I'm going to use here. So, this involves two new classes. In my game package, I'm going to create a new Java class called time. Surprisingly enough, the whole purpose of this class is going to be managing time. So, this class has three methods. The first method is simple enough. Get time. It will get the current time just in however we want to represent it. So I'm just going to create a public static method. It's going to be void. Actually, it's not going to be void. It's going to return a long. It's going to be called getTime. And for now, I'm just going to return system.nanotime, which is sort of Java's built-in way of determining time. And this also means we could change this later. But of course, this is the easy part. The next part is getting something called the delta. The delta is pretty much exactly the issue I was telling you about a few moments ago. The delta is the specific amount of time that the last frame took. It's the time spent between frames. And it won't fix the issue that there can be any amount of time between frames, but at least this way we know the amount of time between frames and we can adjust our game based on that. And that can create the illusion of everything happening consistently. So, and if that doesn't make sense to you, I don't blame you because deltas are really confusing at first, but it will make more sense once you start implementing it. So, I'm going to create the getDelta method, and we have to do a little bit of calculation to find out how much time it took between frames. So, simply speaking, all we really need to find the amount of time between the last frame is to take the time that this frame started and the time that the last frame started and just subtract. So in fact, that's all we're going to do. Now, I'm not going to talk about how we're going to figure those numbers out just yet, but I'm going to create variables for them. So I'm going to create a variable. It's going to be a public, it's going to be a private, it's going to be static, it's going to be static, it's going to be long. I'm sorry, I'm being indecisive on how I want to implement these variables, so just bear with me. And the first one's going to be the current time, which is going to be the time that the current frame started on. And the other one is going to be last time, which is going to be the time the last frame started. And the way this is going to, the delta method is going to work is it's going to return the time this frame started minus the time the last frame started. And if you know basic math, then you'll know that will give you the amount of time between the last two frames, the amount of time that the last frame took, the amount of time between this frame and the last frame. Sorry, I'm trying to think of too many things at once here. Please bear with me. So of course this leaves us with another issue. How on earth do we figure out what these two numbers are? The answer is actually a little bit simpler than you might expect. The logic's a little bit weird, but it's not that hard once you get your mind around it. So, first off, we're going to need another method. It's going to be a static void called update. And this is going to work just like any other update method we have, but this one specifically is just going to make sure that these two numbers right here are accurate. So, first off, we have to determine when we're going to call this. So I'm going to go into my main class, and what I'm going to do is in my game loop, right before the get input, I'm going to call time.update. And you might wonder, well, why am I calling it here rather than with all the other updates? And that's because of what these current time and last time numbers are supposed to represent. They're supposed to represent the start of the frame. So in order to accurately get the start of the frame, it has to be the very first thing called, or called at the start of the frame. So that's why we're calling it there. So let's start figuring out how we get those numbers then. So first off, the last time is where I'm going to start, because the last time is actually the easier of the two. And that's because the last time, well, you think about it, when you enter this method, the current time will be the current time of the last frame, and the last time will be the current time of the frame before that. So since the current time, when this method starts, will be essentially what we want last time to be, then I'm just going to call last time, or excuse me, I'm going to set last time equal to current time. And that logic's a little weird, I know. But just, if you think about it for a moment, it's not that hard. Again, last time, I think I already explained it, so I'm not going to explain it again, but yeah, it's not that difficult, it's just a little bit weird to get your mind around. Now, the only other thing is to get the current time. Well, what's the current time supposed to be? Well, since we're supposed to be the start of the frame is, well, now, then all I have to do is say current time is get time. And this right here will complete the basis of the time class. The only final issue is we need something to initialize current time and last time to be. And what I'm going to do is I'm going to just initialize both of these to get time. So they'll be just initialized to whatever time it is right now. Or, you know what, actually there's a better way of doing this. I'm going to create a fourth method. I don't know why I never did this before, but yeah, I'm just going to create an initialization method. So I'm going to create a public static void init. This will be designed to do exactly what it says on the tin. It's supposed to initialize these variables. So, when we initialize, our current time will be getTime, and our last time will also be getTime. And I'm going to call init just before we enter the game loop. And the benefit of this, rather than initializing them up there, is if I initialize them up there, I don't have much control over when they're called, and I could end up with about a 2-second frame. And once things start depending on the delta, if the delta said that there was some sort of invisible 0 frame that took 2 seconds, the game's going to start 2 seconds ahead of when it's supposed to be, and that's not really what we want. So that's why we're sort of manually intervening when these variables get initialized. So, I'm actually going to initialize last time first, just because I think that'll make it a little bit more accurate. Not much, but, you know, I'll just want every bit of accuracy I can get here. So, and again, right before the game loop, I'm just going to set time.init. It'll initialize our time class. And there we go, we've set up the time class, and this is the first half of our delay system. The second half of the system is the delay class itself. So I'm going to right-click on my game package and create a new Java class. This is going to be called delay. Simple enough. So if I click finish, you'll see I now have a delay class. And now that we have our excellent timekeeping system in place, all we really need to do is we need to figure out how we're going to represent a delay using a class and our timekeeping system. Well, as it turns out, that's a little easier than you might think, because our whole delay system is going to revolve around a single method. Is our delay over yet? Has that amount of time passed? And believe it or not, that's not that difficult to figure out. So, I'm going to create just a public void. It's going to be called, not public void, public boolean called over. And all this method's going to do is it's going to return true if the amount of time the delay is supposed to have has passed, and false if it hasn't. The way I'm going to set the delay is in the constructor. So, I'm going to create a public delay constructor. It's going to take in just some long for amount of time. Really don't see why it should be a long, but why not? It can be anything. And that number right there is just going to be how long this delay is going to be. And from the time the delay class is instantiated, that's when the delay will start. Simple enough. Although actually, I think I'm going to do it a little bit differently than that. So, scrap what I just said. I'm going to also change this to an int time. And the reason I'm going to be an integer instead of a long is because I want to input time in milliseconds. Just because I think that'll be a lot easier to work with than nanoseconds. So, and really I don't think it's reasonable for anyone to have a delay longer than 2.1 million seconds, which would be the maximum time if we did it in milliseconds. So, I'm going to make it integer. And what we're going to do in our constructor is we're first going to keep track of this integer called time. And the way we're going to do this is we're just going to have a variable. It'll be a private variable called time length, guess. Actually, that's probably a better name for it in general. So I'm going to change this integer here to call it to length. Oh, it'll be a private int length. And there. So, now what we're going to do is we're just going to assign this dot length is equal to length. Easy enough. And I'm going to add a couple more methods to this because I decided I want to do this a little differently than I had it set up before. First off, I'm going to create a method called start. So it's just going to be a public void start. And this is just going to start the countdown. So first off, we have to create a boolean to keep track of if we started or not. I'm just going to create a boolean started, I guess. I don't know. It can be called anything. And in my constructor, I'm going to initialize started equal to false. And in our over method, which is going to be the ultimate method we're going to be using to test the delay, if we haven't started, then we're just going to return false, because the delay can't possibly be over if it hasn't even started yet. So, there. Simple enough, but of course we need more than this. So, aside from setting our started variable to true in our start method, so just start equals true, just having the length isn't quite good enough. We need a specific time that the delay is going to end on. So we're going to have to calculate that. It'll be a private long called end time. And in our start method, I'm going to initialize end time to, first off, it's going to be our length. I'm going to multiply length times 1,000 because our current time system is in nanoseconds. So it's going to initialize length times 1,000, and it's going to add that to time.getTime. And simply enough, hopefully this math makes sense to you, it's going to take the current time, and it's going to add on however long our delay is, converted to nanoseconds. And that will be the time our delay is supposed to end. Simple. That logic is simple enough by itself. So anyways, I've really said simple enough a lot, haven't I? But anyways, this system isn't that hard, so... Now, in our over method, what I'm going to do is if time.getTime is greater than our end time, then we're going to return true. And otherwise, we're going to return false. And really, unless I'm missing something, I think this should be everything we need for the basic delay. There are a couple things I could do to clean this up really quick, though, and they're actually pretty simple, so I'm just going to do them. The first thing I'm going to do is I'm going to delete the system we just created. I'm just going to directly return this conditional statement, because really, since that's all we're doing, we're returning that, we don't need to have an if structure, so I'm just going to return that. And the other thing is I want to have a reset button, which, simply enough, is just going to reset the delay. So, public void reset. And all this is going to do in this case is going to just set started equal to false. And that way, the delay... well, I mean, see, what it's going to do is, if we just set started to false, it's always going to return false until we call the start method. So if we reset it, then it's again always going to return false until we call the start method. And that's why we don't have to reset the end time variable, because that's reset whenever we call the start method. So there, that should complete the delay method. So, with that all out of the way, let's go ahead and add that to our attack system. Although really I want this in every enemy, so I'm going to add it into the global, not really global, but higher scope enemy class. And what I'm going to do here is I'm going to have a protected... You know what, first off I'm going to change this target to protected, because just always having to refer to it with get target and set target is just... doesn't make sense to me, so I'm going to change it to protected. So, we've got the target, and I'm going to add a delay. This is going to be the amount of delay in our attack. It's going to be our attack speed. So it's going to be a protected delay called attack speed. Or actually I'm going to call it attack delay. Also, while I'm at it, I can probably change this to just attack range, since it's not a constant anymore. It just makes a little bit more sense, in my humble opinion. And also I want to initialize it in the Cookie Monster class. So, again, I'm just trying to make things clean. I think that's an important principle in coding. Just try to make your code clean. So in here, I'm going to set my attack range to 48. And there. Actually, I could override the... But I'm not going to worry about that right now. Right now, I'm implementing the delay. I'm getting too distracted here. So first off, I need to import it, so Control-Shift-I. And now we have access to the delay class. And all I'm going to do is, as soon as we see the player, then I'm going to... Actually, there's something I also want to add to my delay class. It's going to be whether or not it started. So that's going to just be public boolean active. And that's just going to return started. And the reason is because of the way I want to activate or trigger the delay. And, actually, there's really just... I really don't need that. I'm going to leave it in there anyways because I think it's reasonable. But I'm just going to add one more thing to this. I'm also going to have to check... I'm going to check it first, since it's probably the easiest calculation. If our attack delay is over, and all of that, and this isn't going to work if our attack delay is null. So in the constructor, I'm just going to initialize attack delay to a new delay of length 0. So there. I'm sorry that I'm a little bit flustered right now. I'm not used to my new and, I think, improved delay system, so just give me some time to get used to it, and yeah. So, yeah. Anyways, that should fix that error. And right now, if I run it, it should do exactly what it was doing before. Assuming it doesn't crash, of course. So if I hit run, then it's not attacking at all. That is very interesting. And why is, oh. I never actually... Silly me, I never actually started the delay. So, attack delay dot start. That's a pretty good reason why that, wouldn't work. Okay. So, fair enough. And... You know what? I'm going to change this back to private. That right there. I'm actually going to change all of these to private. I want all of these to be done with, with methods, just because I think that's a lot cleaner, because that way we can change the underlying system later on, and I wouldn't have to change any code anywhere other than the enemy class. So I realize this is going to be a little bit weird, but I'm just going to do it really quick. It's going to have a public void, void set attack range. It'll take in an int range, and it's just going to set attack range equals range. I'm also going to initialize my attack range to attack range equals, and I'm going to set it equal. What should I set it equal to? I'll just set it equal to 48 like I had before, because I think that's a nice initial attack range, because we can always change it. I need to delete that code. So now I just need public void set attack delay. Just going to take int time, and this is just going to set attack delay equal to a new delay. Not new attack delay, new delay of length time. And I could call start, but actually I think I can do a better job than just calling the start method, because that's not really what I want here, is it? So I'm going to create another method in my delay class, which is just going to be called end. So public void end. What this will do is just instantly finish the delay, no matter how long it is. So, the way I'm going to do this is simple enough, so I'm going to set started equal to true, and end time equal to 0. That way, it will always be over if I call this method. So, what this will let me do is I can call attackDelay.end to just instantly reset the attack delay. Or, I shouldn't say reset, that's not a good word for it, but it's a way of just making sure that we can attack immediately no matter how long our attack delay is. And I'm also going to add one more method, which is called reset attack delay. And what this is going to do is it's going to exactly what it sounds like. It's going to reset our attack delay. The way I'm going to do this is just attack delay dot reset. Actually, I don't even need to reset it. I can just do attack delay dot start again. And I believe based on our code, that should reset it. So yeah. Yeah, it should reset it. So there we go. And I shouldn't call it reset. I should just say restart. Okay, so there. Now we have a nice, simple set of methods that can be used to control our enemy's attack. Or not their attack, but their attack delay. So, what I'm going to do is in our constructor, I'm just going to set attack delay, set attack delay. I'm going to set it to attack delay of 200 milliseconds. And in our attack method, all we're going to do is we're going to print that out, and then we're going to restart attack delay. So there. Let's see what happens. If I hit run, okay, it does not appear to be working. And why is it not working? And I think I found the problem. If you look right here, milliseconds times 1,000 does not decrease it to nanoseconds. That decreases it to microseconds. So our delay wasn't 200 milliseconds, it was 200 microseconds. So I actually need to multiply this by 1,000,000. And that should give me milliseconds. So now if I hit run, and run up to the monster, the delay is working, as you can see. And the important thing about this delay is note, it is not interrupting the flow of the game. You could do thread.sleep, that's a very simple way of doing delay, but it would freeze your entire game when you did it. And that's why we have this slightly more advanced delay system, because that way we can have the game keep running and still have delay going on. So there. That has added a delay. And now that we've done that, we can finally start adding basic damage. So, this is actually going to be the easy part of it. It's going to be, excuse me. I'm sorry, I just had a brain fart really quick, sorry. It's going to have some variable right here. It's going to be private. I'm going to check my statistics class really quick for something. Stats. Okay. It's going to be an integer called damage. And the reason I chose integer is because we're using our health to be kept track of as an integer, so I just don't want to end up mixing floating point damages with integers, because it doesn't usually end very well. Excuse me, I should call it attack damage. And what this should do is it should give us a very simple way of interacting with, or excuse me, it should give us a variable that controls us how much, it should give us a variable that controls how much damage the enemy is doing. It's going to be public void, call it set attack damage, int amount, and all this is going to do is again attack damage equals amount. Field attack damage is not used, well, it will be pretty soon. So, And I should have a way of getting attack damage. So aside from setters, I'm also going to have a getter for it. So public void get attack damage into mat, or no, don't take any parameters. Going to return an integer. Don't know what I was thinking there. Return attack damage. So what I'm going to do here is I'm actually just going to test death and attacking in the same order. I'm going to have it damage itself. So it's actually going to be hurting itself. And I'm pretty sure that in our stat object we added a method for doing damage. Yes. So, as its enemy is a stat object, we should have access to it. So I should be able to just do damage to itself by get attack damage. And then just print out an enemy's health. And then I'll add on get current health plus space, or actually plus slash plus get max health. In case you're wondering, these methods are coming from the stat object class. We're inheriting them. So this should be a very basic damaging system where the enemy damages itself. So if I hit run, then the enemy should be damaging itself, but it's not. And the reason for that is its attack damage is 0. It's actually one more issue. Hang on one second. I think I noticed something weird. Okay, that is an issue. Because okay, I need to actually move this attack delay. I need to put it in a separate if statement, because if I keep it in here, then if our attack delay is happening, or excuse me, if we can't, how should I put this? If we're waiting for our attack delay, but we're still within range, and then we're just going to keep chasing in this case. We want the enemy to stand still if he can attack, but he just hasn't had his attack delay pass. So I'm going to move the attack delay into a separate if statement, and that's going to just be right here. If attack delay dot over. Then we attack. And I should just fix that quick problem I noticed. So now, now we get some very, very strange behavior. Not quite sure why that's happening. I gotta be honest there. If I just change it to line of sight, is that gonna change it? Okay. If I add on the distance, is that what makes it behave weirdly? Okay, one second while I debug this. And it was actually really, really simple. I need parentheses. Silly me. It's what I get for hating parentheses, I guess. So now, as you can see, it works fine. But of course the enemy still isn't damaging anything, because we never set the enemy's damage to something. So I'm just going to initialize attack damage in the constructor equals 1. That way, it should be at least doing damage to itself. And it eventually will kill itself, because it's damaging itself. So, that's easy enough. Now all we have to do is delete the unnecessary imports. And to get this to damage the player instead of itself, all we have to, we can actually keep that line, all we have to do is change it to target.damage. Get target.damage. I will never get used to that. Damage. Cannot find symbol. Well, there. Am I not getting... I know why. I know exactly why. Where is the get target method? I know it is in here somewhere. Right here. Stat object, not game object. It returns a stat object. And now you should work. Array list of game objects. Control-Shift-I. Okay, there we go. And now everything should work just fine. Except, of course, I never actually am displaying my player self. So I should just do player self, player.getCurrentHealth, or get target.getCurrentHealth, plus getTarget.getMaxHealth. And now, it's damaging the player instead. Except the player doesn't actually die, because we haven't programmed it to die yet, so the player just keeps going into the negative forever. We have the invincible player. It's amazing. Of course, I'm just going to get rid of this line because it's not necessary. And, yeah. So, actually, just because it's a little bit more reasonable, I'm going to change the initial delay to 500. Just because. I think it makes more sense than having the enemy that attacks infinitely fast. I'll just delete this. And there we have our very not basic combat system going on. It's definitely very far from complete, but now we have an enemy that can attack the player. And it can do damage. So it's a start. And you know, even though I'd usually wait till the next video to do this, I'm going to go ahead and do it here so we can focus a little bit more specifically on the combat system in the next video. I'm going to clean up the enemy class, and I'm also going to do a very global cleanup. So this video will be a little bit longer than normal. I'm sorry if you hate long videos, but yeah, we're just going to quickly clean this up. So first off, our attack, look, chase, and death methods are going to be pretty similar for most of our enemies. So what I'm going to do is I'm going to actually use the methods we've created here. I'm going to, at the chase method, because this is pretty much what's going to happen in every single case, I'm going to move the chase method into the actual enemy class, because, let's face it, we're going to be chasing the enemy pretty much the same way with every single enemy. The only issue is now we need the damping constant that we don't have, but that's okay, we can just copy it. And if later we decide we don't like this, we can change it. So it's easy enough. And now we need the look method, which is also going to be pretty much the same for every single enemy. And pasted code, import nodes, blah blah blah. Yes, import. Okay, now all we need is the range of sight. So that's actually going to be another variable. So private float. I'll call it sight range. And am I a constructor? I'm going to initialize sight range to 128. And just gonna delete this now, because I don't need it. And this. And look how much cleaner it is now to set up a basic enemy. So, now, all we need to do, change this variable to sight range, and add a setter for it. So, just public void set sight range, and this will take in some float amount. Pretty sure I set it to a float, didn't I? Yes, okay. And it's just going to set sight range equal to amount. I should just call it distance, that's probably a little more descriptive, because it's the unit of distance. Okay. I'm actually going to group my attack and death methods together now. Because why not? And also our death method's going to end up being pretty universal. So I'm going to cut the death method and just paste it in here as well. Because even though we're just removing, later on, it's going to be pretty much the same for everything. So for now, I'm just going to move it over. And now we can also delete every single import we had in the Cookie Monster class. And this right here, everything we need for the Cookie Monster class. That's it. It's that simple. So, and really if we wanted to, we could even move the attack method over. But, you know what? I think I will. So, I'm just going to move the attack method over. And I'll delete that. And now, now pretty much those methods will apply to every single enemy we create, and we'll create a little bit of a better system of managing different attack methods, like whether we're using melee attacks or ranged base attacks or shooting fireballs or whatever. But for now, this is good enough. So, there. And now all we have to do is we have to deal with the more big and global cleanup issue. And that has to do with our new time system. Because right now, this delta method right here has the potential to cause a pretty significant change in our code. You know, it's not... I shouldn't say it's groundbreaking, but it's pretty significant. And that is, if I go to my main class, you'll notice that right now, if I can find it... Aha, right here. We have set so our game will only run properly at 60 frames per second. At even 59 frames per second or 61 frames per second, our game's not going to work properly. We are locking ourselves in to a set frame rate. This get delta method will allow us to be liberated of that constraint, allow us to have our game run at any FPS setting we want. So I'm just going to delete that and VSync enabled. And what we're going to do now is we're going to set up our game so that it can run at any frame rate. So be prepared, because when I hit this run button right here, some really freaky things are going to happen. So hit run, it starts off looking just normal. Now let me just tap the right arrow key. I'm gone. Our player is running way too fast. I don't even know if you can see that because of the frame rate I'm recording at. But also you might be able to see that he's also getting really weird and pixelated. Those are just some of the unfortunate facts that come with dynamic frame rates. If we get close to our cookie monster, it's actually extremely challenging, and I've lost a player. But the reason for this is we're assuming that every action is going to have specifically the amount of time that 60 frames per second would have between them, which would be 16 milliseconds. And right now that's closer to 1 millisecond. So, in a sense, our game is running 16 times too fast. The way we're going to fix this is in our player class, and every class we create hereafter. So where is my player class? There it is. Okay. So in our move methods, the first thing we have to do is we have to include multiplied by get delta. And this actually will not fix our problem. It will make it worse if I just leave it like this. So in order to fix this, what I'm going to do is I'm going to change my delta value. Because I want actually a double. Actually, do I really want a double? I think I want a double, but I'm not sure. I might actually want to float. Where did my player class go? There it is. Okay. Yeah, I want to float. Never mind. Never mind. Okay. And the way I'm going to get this is I'm just going to have a delta constant. And the reason I'm going to do this is this will just allow me to be a little bit closer to the way I had it before. That way I don't have to just go in and change every single number in my game. I'm just going to change my delta value to get... how should I say this? Rather than go through all my classes and change my speed values to account for the delta, I'm just going to alter my delta value to account for the speed. And that will work because as long as the delta is still representing the amount of time between frames, it'll still be accurate. So I'm just going to create a public static, not private static, public static final float, I'll call it damping because that's what I'm calling every constant like this. I'm going to start off with 0.01. And I'm just going to multiply this by damping. And this will be some value that and this will just alter our delta value by a certain amount. And right now, one more compiled with errors. Multiply by time.getDelta. Time.import time class. Yes. And there. So our player is now... Okay, that's obviously way too fast still. So I'm going to decrease the damping value until I get something that's reasonable. Okay, apparently this value is going to be incredibly small. That actually seems to work. And now I've got our game running at any frame rate we want, and in addition, well, first off, if I trigger the monster just for fun, he is staying on me. So there. But yeah, that's just for fun. And if I decide that's too fast, I can change it. Although, because I don't like having an incredibly small decimal number, I'm going to just change this to division, just because I think it makes more sense to have a giant number than it does to have a really tiny decimal number. But that's just me. And I do think a million's still a little bit too fast, so I'm going to increase it to 2 million. Actually, that's not a million, that's 20 million, isn't it? Yeah, it's 20 million. Sorry. That's a little bit too slow. So now I'm just playing to get my values to work. That's still a little bit slow. We'll do 5 million. That's kind of close to what I had before. So now I'm just going to try it out without the delta. I'm just going to compare. And this way, I'll just know how close my times are to what they were before. Whoops. All I need to do now is just change back the set frame rate. And we'll see how the player is himself. Okay, so I am moving a little bit faster. Okay. So I'll just keep adjusting. In time, delta to 1.6 million. Still too fast. Let's just try 20 million again. I don't know, it just feels too slow to me. 18 million? Okay, I like the feel of that. So, I'm going to keep it at 18 million. So now that we have our damping constant in place, we should be able to apply the exact same technique to our enemy. So right now he's just chasing us like crazy, but if I go to my enemy class, then I go here, then I should just have to multiply this times time.get time, or delta, and I should end up with a speed that's somewhat close to what it was at before. And look, I now have it working at pretty much the speed that I had it at before. So, there. The only difference is now my game will run properly at any frame rate at all. I can also run over and pick up the item just for fun. And yeah, so there. I will, however, change it back to 60 FPS. And by the way, VSync enabled what gets rid of those weird lines you saw when I was going insanely fast. So, nope. I'm going to set it back to just a set frame rate of 60 FPS, even though now I can run at any frame rate. And the reason for that is, I think it's more realistic my game can end up being played at 60 FPS, and also, if you're on a laptop, having a game run at as fast as it possibly can is really, really bad for your battery life. So, I'm just going to keep it set to 60 FPS. But now if we wanted to, I could change this to 30 FPS, and my game will still run just fine, although it looks rather jerky compared to what we had it at before. If I could even set it to 10 FPS, and it's still running just fine, even though it looks really ridiculously laggy. But, yeah, there you go. So, I'm pretty sure that's all I want to cover in this video. I've already gone on for probably well over an hour now, so I hope you'll forgive me for the extra long video, but even though it probably doesn't seem like we achieved all that much in this video, I promise you, this was probably one of the most significant videos we've done so far, because we've just made our whole game a lot more dynamic and changeable. And really, that's the whole point of this, the way we're doing everything right now. We could make something that works exactly like our final version in about a tenth of the time we're taking, but you wouldn't be able to change anything. It would be really painful to work with, you wouldn't be able to expand it, and you wouldn't be able to make anything better. Actually, 1/10 of the time is probably an extreme exaggeration. It's actually probably closer to about 10% faster. It's not that much faster. But still, this way, we have just a really nice dynamic system, and that's one thing I really want to go for in this, because I want you to be able to go out and make your own game using this system, and I want you to be able to make it really, really easily, using all the code and systems we've done so far in the series. So, thank you. Hope you understand. Hope you enjoy.